Welcome to this video. In this video, we shall discuss vapor pressure, and Raoult law. We shall discuss vapor pressure of liquids and Raoult law. Vapor pressure of volatile liquid and Raoult law. Before we go into the topic fully, there are some concepts you have to know that will make you understand this topic. The first thing you have to know is volatile substance. You have to know the meaning of volatile substance. You have to know the meaning of non-volatile substance. You have to know the meaning of evaporation. And you have to know the meaning of condensation. Let us start with what is volatile? Volatile substance. Volatile substance. A volatile substance is a substance that can evaporate at room temperature or below. Any substance that can evaporate at room temperature or below is volatile substance. Any substance that can evaporate at room temperature or below is known as a volatile substance. And what are the examples of volatile substance? You have to know example. Example, we have ethanol, we have water, we have acetone, we have gasoline, we have benzene, we have toluene, etc. These are examples of what volatile substance that evaporates at room temperature or below. You have to know this second thing, which is what? Non-volatile. Non-volatile substance. What is non-volatile substance? Non-volatile substance is any substance that cannot evaporate at room temperature or below. Any substance that cannot evaporate at room temperature or below. That is non-volatile substance. Any substance that cannot evaporate or that doesn't evaporate, that cannot evaporate at room temperature or below. Any substance that cannot or that does not evaporate at room temperature or below. What are the examples of what? Of non-volatile substance? We have urea. Urea is an example of non-volatile substance. We have salt. It's an example. We have glucose, etc. These are substances, non-volatile substances. These are substances that do not evaporate at room temperature or below. Non-volatile substance, any substance that does not or that cannot evaporate at room temperature or below. And these are examples. And another thing you have to know the meaning of evaporation. You have to know the meaning of evaporation. Please, you can pause the video and write all this out. Please don't forget, subscribe to our YouTube channel. Please share this YouTube channel with your friend. Please comment about this on this YouTube channel so that I can give you more topics in chemistry, in physics, in math, in biology, on JUPEB and JAM. This is a channel, Neo-Tisa School, that give the best on JAM, WAEC, UTME, and JUPEB. Please share it with your friend and comment and subscribe and like. Please, thank you. Let's move further. What is evaporation? Evaporation. Evaporation. What is evaporation? Evaporation is a process by which liquid change or is transformed toward vapor. Evaporation is a process by which liquid is transformed into what? Vapor. It's a process by which liquid is transformed into what? Vapor. This is a process by which liquid is transformed into vapor at any given temperature. A process by which liquid is transformed into what? Vapor at any given temperature. Don't forget the difference between evaporation and boiling. Let me quickly give you that. When you have evaporation, it's different from what? Boiling. Take note. Evaporation is different from what? Boiling. Evaporation can occur at any temperature. Take note of that. Evaporation can occur at any temperature. For example, for water, evaporation of water can occur at 0 degrees C. It can occur at any given temperature. Evaporation has no fixed temperature. It occurs at any temperature. This one, it occurs at any temperature. But boiling occurs at a fixed temperature. Boiling occurs at a fixed temperature. For example, the boiling of water is 100 degrees C. Can you see water boils at 100 degrees C? That means boiling of water is at a fixed temperature. Pure water, when you have a pure water, a water that is pure, the boiling point is 100 degrees C. But evaporation can occur at any temperature. And this evaporation occurs at the surface of liquid. That's another difference between the two. Evaporation occurs at the surface of liquid, while boiling occurs on the entire body of the liquid. On the entire body of the liquid, boiling occurs. That's why when you are boiling your water, you see your water will be boiling. Boiling occurs on every part, on the whole body of the liquid, while evaporation occurs at the surface of the liquid. And you have to know, for you to have the knowledge of vapor pressure and Raoult law, you have to know the meaning of evaporation. I said evaporation is a process by which liquid is changed into vapor at any given temperature. Please take note of that. Let us move to another concept you have to know, which is condensation. Condensation. You have to know the meaning of condensation. Let me take water to kill my taste. Condensation. What is the meaning of condensation? Condensation is a process by which vapor is transformed into liquid. It's a process by which vapor is transformed into liquid. A process by which vapor is transformed into liquid. Process by which vapor is transformed into liquid. Let us look at this. When you have condensation, which I told you, a process by which vapor is transformed into liquid. That means for we to have vapor pressure simply means evaporation plus condensation. Vapor pressure simply means evaporation plus condensation. But before we look at that, let us consider a volatile liquid in an open container. Let us consider a volatile liquid in an open container. Let us look at a volatile liquid in an open container. When you have an open container containing a volatile liquid, let me assume the volatile liquid is what? Liquid A. Liquid A. You have liquid a volatile liquid A in an open container. Liquid A. This is liquid A. Open container, that means it is open at one end. And look at this. This is the surface of the volatile liquid in this open container. The molecules at the surface of the volatile liquid are called what? Surface molecule. Surface molecule. Surface molecules. And any molecules below the surface molecules are called bulk molecules. Any molecules below the what? Surface molecules. Any molecules below the surface molecule. Let me give it like this. Look at this. Please don't mind my diagram. This is A is still the same liquid A. Liquid A. The molecules on the surface or at the surface of the volatile liquid are called surface molecule. While the molecules of liquid A below the surface molecule are called bulk molecules. Bulk molecules. Take note of that. These surface molecules, they possess some characteristics. The surface molecules have high kinetic energy. High kinetic what? Energy. They have high kinetic what? Energy. These surface molecules, they possess low force of attraction. Low force of attraction. Low force of attraction. Take note of this. These surface molecules, they possess high kinetic energy. These surface molecules, they possess low force of attraction. And the force of attraction, take note, this force of attraction act parallel to the wall, to the surface of the liquid, and it also act downward in the liquid. Look at this. This is what I mean. When you have this is the surface molecule. Let me just put 2. Let me put 2. This is the surface molecule. I told you that this surface molecule, their force of attraction act parallel to the wall, to the surface of the liquid. This force of attraction act parallel to the surface of the liquid, and it acts downward. It acts downward. That means the force of attraction of this surface molecules acts parallel to the surface of the liquid, and it acts downward into the water, into the liquid. Take note. The force of attraction acts parallel and also downward. Take note. And don't forget, the evaporation will occur in this open container. Why? What is evaporation? Evaporation is what? When liquid is being transformed into what? Into vapor. The liquid will be transformed into vapor. Evaporation will occur at the surface. The surface molecule will evaporate. Why? Because they have high kinetic energy. The surface molecule will evaporate because they have high kinetic energy. The surface molecule will change into vapor. Will change into what? Vapor. Why? Because of their high kinetic energy. And when they change into what? Vapor, they escape into the what? Atmosphere. The vapor escapes into what? Atmosphere. That is why evaporation occurs in an open container. Evaporation occurs in an open container. And since evaporation occurs in an open container, the weight of the liquid, the remaining liquid in the container decreases. the weight of the remaining liquid in the container what decreases. Why? Because evaporation has what occurred. A process by which your liquid is changed into what? Vapor. And the vapor will escape into the what? Atmosphere. That means vapor escape into the what? Atmosphere. In an open container, the evaporation occurs in an open container. The weight of the liquid in an open container decreases due to what? Evaporation. Take note. That means in this open container, what occurs? Vapor escapes into the what? Atmosphere. 2. The weight of the liquid in the container decreases. Take note. Not only the weight, the volume. Take note. The volume of the liquid. The volume of the liquid in the container also decreases. Decreases. Take note of that. Due to what? Evaporation. Due to the fact that what? Vapor has escaped into what? Atmosphere. Why does evaporation occur on the surface of a volatile liquid in an open container? Because the surface molecules, as well, the surface molecules possess high kinetic energy. Please take note of that. That means in an open container, vapor pressure cannot occur. Take note. Vapor pressure does not occur in an open container containing volatile liquids. Take note of that. Please take note of that. Vapor pressure does not occur in an open container containing volatile liquid. That is that. I told you vapor pressure does not occur in an open container containing volatile liquid because the vapor will escape. Then let us look at a closed container. A closed container containing volatile liquid. 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 When you have a closed container containing volatile liquid, liquid A, I told you these are the surface molecules which possess high kinetic energy. They possess high kinetic energy. What happened in this case? I told you in an open container, vapor could not escape. Evaporation occurs in an open container in which the volatile liquid change to what? Vapor. Evaporation is the process by which liquid or a substance, liquid change into what? Vapor. In an open container, there's evaporation. The vapor will escape. But in a closed container, the vapor will not escape when the liquid change into vapor. The vapor will not escape. Therefore, in a closed container, there is vapor pressure. Vapor pressure occurs in a closed container. Vapor pressure simply means, I told you that vapor pressure simply means evaporation plus condensation. Evaporation plus condensation. Vapor pressure simply means evaporation plus what? condensation. What do we mean by this? Look at this. In this case, evaporation will occur. The volatile liquid from the surface, because they have high kinetic energy, they will change into what? Into what? Gas. They change into what? Gas. Into vapor rather. The what? The volatile what? Liquid on the surface of the liquid will change into vapor. But the vapor will not escape into the atmosphere. Why? Because it has been trapped. The vapors have been trapped. Then what will happen? The vapor condensation will occur. Condensation will occur. Then in the case where you have what? Evaporation and condensation. In that case, we are going to have vapor pressure. Vapor pressure. There will be a point in which the number of liquid leaving the what? The surface of the molecule the number of liquid leaving the surface of the volatile liquid will be equal to the what? The number of vapor that is returning into the what? Into the liquid. What do they mean by that? When you have this, look at this. In a case where you have liquid to what? Vapor, this process, liquid to what? Vapor, is known as, liquid to vapor is known as what? Evaporation. Then the process in which you have vapor to what? Liquid is known as what? Condensation. Then at a point in which the number of liquid molecules leaving, the number of liquid molecules, let me assume the number of liquid molecules leaving the surface of the volatile liquid, let me say is 10. When it is equal to the number of vapor returning to the liquid, when they are equal, at that point, equilibrium occur. Equilibrium what? Occur. Equilibrium state is a state in which the rate of what? Evaporation is equal to the rate of what? Condensation. When the rate of evaporation is the same thing as the rate of what? Condensation. When the number of molecules of what? Liquid leaving is the same thing as the number of molecules of what? Vapor returning. That stage is known as what? Equilibrium state. And that equilibrium state is also known as what? Vapor pressure. Vapor pressure. Vapor pressure. Vapor pressure. That equilibrium state is known as what? Vapor pressure. Let me repeat myself. In a closed container, the surface of the volatile liquid in a closed container will change into vapor. The vapor has been trapped. It could not escape into the atmosphere. It will return into the what? Into the liquid. Then the point at which what? The number of vapor leaving and the number of what? Liquid leaving is the same thing as the number of vapor entering into the liquid. When they are equal, that state is known as what? Equilibrium state. Equilibrium state. At that equilibrium state, we have a vapor pressure. At that equilibrium state, we have a vapor pressure. Then what is vapor pressure? Vapor pressure. This is the pressure exerted by a vapor on the surface of a volatile liquid. Write it down. Vapor pressure. Vapor pressure. Vapor pressure. Vapor pressure. Write it down. I say, this is the pressure exerted on the surface of a volatile liquid by vapor. The pressure exerted on the surface of a liquid by what? Vapor is known as what? Vapor pressure. The vapor pressure. The pressure of a vapor on the surface of a volatile liquid. The pressure of a vapor on the surface of a volatile liquid. The pressure exerted on the surface of a volatile liquid by what? Vapor is known as what? Vapor pressure. Please take note. Now, this vapor pressure can occur in a closed container containing what? Containing volatile liquid. Take note. Vapor pressure can occur in a closed container containing what? Volatile liquid. But in an open container, vapor pressure cannot occur. Why? Because the molecules of the liquid will change into vapor and the vapor will what? Escape. But in a closed container, as there's what? Evaporation, there will be what? Condensation. Then when the rate of what? Evaporation is the same thing as the rate of condensation, at that state we call it what? Equilibrium what? State, which is what? Vapor pressure. Vapor pressure equilibrium. Take note of that. Let us look at what factors affecting vapor pressure. Factors affecting vapor pressure. Number one, nature of substance. Number one, nature of substance. Factors affecting vapor pressure. Number one, nature of substance. Number one, nature of substance. Nature of substance. When we look at nature of substance, we can divide the substance into two. We can divide the substance into two. We have volatile substance. Volatile substance. We have non-volatile substance. I told you example of non-volatile substance. We have salt, we have sugar, we have urea. The example of non-volatile substance. Take note. The vapor pressure of non-volatile substance is what? 0 or very low. Take note of that. The vapor pressure of non-volatile substance is what? 0 or very low. Because non-volatile substance cannot, I told you earlier that non-volatile substance cannot evaporate easily, cannot evaporate at what? Room temperature or below. Therefore, since they cannot evaporate, their vapor pressure is what? Very minimum or 0. The vapor pressure of non-volatile substance is what? 0. But vapor pressure of non-volatile substance is not 0. It's not 0. It is maximum. It is maximum. The vapor pressure of non-volatile substance, like ethanol, like acetone, like methanol, like what? Toluene, like toluene. The vapor pressure is not equal to 0. That means when you have volatile substance such as ethanol, acetone, methanol, toluene, their vapor pressure is not equal to 0. That means their vapor pressure is maximum. Vapor pressure occur on non-volatile or on volatile substance. Vapor pressure occurs on volatile substance. Volatile substance, vapor pressure occur on volatile substance, such as ethanol, acetone, methanol, toluene. And I told you volatile substance is substance that evaporate at room temperature or below. They have maximum vapor pressure. That means their vapor pressure is not 0. Their vapor pressure is what? Maximum. Take note. Volatile substance, their vapor pressure is maximum. Let's move further. Please, let's move on. Under nature of substance, another factor we have to consider under nature of substance is intermolecular force. Intermolecular force. Take note of it. Vapor pressure is inversely proportional to intermolecular force of attraction. Vapor pressure is inversely proportional to intermolecular force of attraction. What do we mean by this? If intermolecular force of attraction between the molecules of the liquid is weak, the vapor pressure will be high. Take note of that. Let me repeat. If the intermolecular force between the molecules of the liquid is what? Is a weak force, the vapor pressure will be what? High. But if the intermolecular force between the molecules of the liquid is very strong, vapor pressure will be what? Low. Let me repeat myself. If the intermolecular force between the molecules of the liquid is weak, vapor pressure will be what? High. If the intermolecular force between the molecules of the liquid is weak, vapor pressure will be high. If the intermolecular force between the molecules of the liquid is very strong, vapor pressure will be what? Low. Take note. Vapor pressure will be low. Please join our WhatsApp group. It's below this video. You see it in what? Comment section. It's below. Please join it so that we can give you what? Best. Please, it's below the word. The link is below the word. The comment section. Please, the WhatsApp group. Please punch it, press it, punch it, and so join the word. Join the group. Let's move further. I told you, if the intermolecular force is a weak intermolecular force, the vapor pressure will be high. If the intermolecular force is a strong intermolecular force, the vapor pressure will be low. Let us look at this. Water and let me put acetone. Two of them are volatile liquid. Then which one has stronger or higher vapor pressure? Which one has higher vapor pressure? Let us look at this. Water. The bond in water is hydrogen bond. While the bond in acetone is what? Dipole. And take note, dipole is a weaker force. Compared to hydrogen bond. Dipole is a weaker force compared to what? Hydrogen bond. This one, the bond in acetone is very weak. The bond in water is hydrogen bond. Is stronger than what? The dipole in what? Acetone. Now don't forget, I told you that if the force of attraction is weak, it's a weaker force of attraction, the vapor pressure will be what? High. If the force of attraction is a weak force of attraction, the vapor pressure will be high. If the force of attraction is a strong force of attraction, the vapor pressure will be low. If the force of attraction is a strong one, the vapor pressure will be low. If the force of attraction is a weak one, the vapor pressure will be high. Between these two, which one has a weaker force of attraction? Acetone, weaker force. This one has a stronger force. Therefore, which one of them will have higher vapor pressure? Acetone, the one that has a weaker force. That means I can say vapor pressure of acetone is greater than vapor pressure of water. Take note of that. Vapor pressure of acetone is greater than vapor pressure of water. Let me give you another example on this. Let us look at this. Let's look at this. Where you have trihydric alkanol. Let me say glycerol. CH2OH. You have glycol. This one is used as an antifreeze. That's another topic for another day. Glycol. CH2OH. This one is dihydric alkanol. Then when you have ethanol, you have this ethanol, C2H5OH. This one is monohydric alkanol, mono, hydric, he has 1 OH, dihydric, 2 OH, trihydric, trihydric, he has 3 OH, dihydric, he has 2 OH, mono, he has 1 OH. Let us look at that. Which one of them we have the highest vapor pressure? This one has 3 hydroxyl group. This one has 2 hydroxyl group. This one has only 1 hydroxyl group. And the more the what hydroxyl group they are, the higher the hydrogen bond they will form. This one has 1 hydroxyl group. This one will form the what? The lowest, the weakest hydrogen bond. This one has the maximum 3 hydroxyl group, more the most hydroxyl group. This one will form what? Maximum hydrogen bond. Why? Because it has 3 what? Hydroxyl group. This one form the what? Maximum hydrogen bond. Maximum hydrogen bond. Why? Because maximum hydrogen bond. Why? Because it has what? 3 hydroxyl group. This one form what? Minimum hydrogen bond. Minimum hydrogen bond. Because it has 1 hydroxyl group. It has 1 hydroxyl group. It will form the minimum hydrogen bond. This one has 3 hydroxyl group. It will form the what? Maximum hydrogen bond. This one has 2 hydroxyl group. It will form intermediate hydrogen bond. Take note. Then which one of them will have the highest vapor pressure? This one that has the lowest, the minimum hydrogen bond. They all exhibit, they all form hydrogen bond. But this one will form the maximum hydrogen bond, which will be the strongest hydrogen bond. This one form maximum hydrogen bond. Why? Because of the 3 hydroxyl group, it will form the maximum hydrogen bond, which is known as well the strongest hydrogen bond among the 3 of them. Then this one has the minimum hydrogen bond. Therefore, this one will have the weakest hydrogen bond. Since it has the weakest hydrogen bond, it will have the higher vapor pressure. That means I can say vapor pressure of ethanol is greater than vapor pressure of glycol. Then the one of that glycol is greater than vapor pressure of glycerol. This one has the lowest vapor pressure. Why? Because it has the strongest hydrogen bond. This one has the highest vapor pressure because it has what? The weakest hydrogen bond. Take note of that. Let us look at another factor affecting vapor pressure. Number 2, another factor, which is temperature. Temperature. Let's look at temperature. Temperature. The second factor that affects vapor pressure. Temperature. Take note. Vapor pressure is directly proportional to what? Temperature. And it's the same thing directly proportional to what? Evaporation. Vapor pressure is directly proportional to temperature. The same vapor pressure is directly proportional to evaporation. But let's look at temperature only, because we are looking at our factors that affect what? Vapor pressure. That is temperature. That means vapor pressure is directly proportional to what? Temperature. That means the higher the temperature, the higher the what? Vapor pressure. Look at this. When you have water at 60 degrees C and you have the same water at 30 degrees C, I told you as vapor pressure increases, temperature increases. As temperature increases, vapor pressure increases. Which one has higher temperature? This one. Therefore, this one will have a higher vapor pressure. Take note, higher vapor pressure. This water at 60 degrees C, we have higher vapor pressure. And what is the graph that shows relationship between vapor pressure and what? Temperature. The graph that shows relationship between vapor pressure and temperature. Take note of this graph. That is what the graphical representation of vapor pressure and temperature. Take note of that. Let's move further. Take note. Size or shape of container. Note. Note. Size or shape of container. Container does not affect vapor pressure. Take note of that. Size and shape of container does not affect vapor pressure. Size and shape of container does not affect vapor pressure. That means I've given you everything about vapor pressure. I told you vapor pressure occurs in a closed container containing volatile liquid. Vapor pressure simply means for evaporation plus what? Condensation. For vapor pressure to occur, there must be evaporation, there must be what? Condensation. That means the rate of what? Of evaporation must be equal to the rate of what? Condensation. And that occurs in a closed container. Vapor pressure does not occur in an open container. Take note of that. Please stay out. Vapor pressure does not occur in an open container. It only occurs in a closed container. Vapor pressure, this is the pressure exerted by a vapor on the surface of a liquid. The pressure exerted on the surface of a liquid by a vapor. Take note of that. The vapor pressure is the pressure exerted by a vapor on the surface of a liquid. The pressure exerted by a vapor on the surface of a liquid when there is evaporation and condensation. It occurs in a closed container. Let's move further. Let us look at Raoult law. Raoult law before we solve some numerical questions from your JUPEB past question. Let's look at Raoult law. Raoult law. Raoult law. Raoult law. Yes. It's good to be good. Please join our YouTube channel. This is the best online lecture you can see. We do physical lecture also. You can call any one of those two numbers on your screen for physical class on JUPEB and what WAEC and what JAM. Your 300 above is certain in your JAM, and your 3 A's is certain in your JUPEB. Your JUPEB, your 3 A's is certain. Once you are with us, we are going to give you all the topics you need to know on comprehensive and lecture, the concept of all the topics you need to know in physics, in chemistry, in biology, and math. For physical classes, you can call one of those two numbers. For online lecture, you can call one of two numbers on your screen. Then you will see our WhatsApp link below the video on the comment section. Please, you can click it to join the WhatsApp group. Please subscribe to our YouTube channel, share it with your friend, comment and like. Please do this. May God help us. Let's move. Let's look at Raoult law. Before we look at the Raoult law, let us look at vapor pressure of two volatile liquids when mixed together. Let's look at vapor pressure of two volatile liquids when mixed together. Let us look at this. Let me assume we have liquid A, this liquid A. We have plus liquid B, this liquid B. I'm sorry for my diagram. Please hope you understand what I'm drawing. Liquid B, volatile liquid B. I told you vapor pressure occur in a closed container containing volatile liquid. This is liquid A containing volatile liquid. Yeah, a container containing volatile liquid A, and there's vapor pressure occurring on the surface of the what? Volatile liquid A. The vapor pressure is known as what? Vapor pressure of pure liquid A. When you see this, it means vapor pressure, P not A, vapor pressure of pure liquid A or liquid A. Vapor pressure of liquid A. Liquid A is pure because it's a compound in liquid form. Liquid compound. It could be toluene, ethanol, benzene, acetone. It could be water. They are pure substance. They are pure substances. They are pure what? Substances. This is what? The vapor pressure of pure liquid A. That is P naught A. The vapor pressure of pure liquid A. For this, we have vapor pressure of pure liquid B. P naught B is for vapor pressure. Vapor pressure of pure liquid B or liquid B. I say vapor pressure of liquid B or pure liquid B. Vapor pressure. When two of them are mixed together, when they are mixed together, you have this. You have A, B, A, B, A, B. You have, this is for solution. Solution. This is liquid A with what? Vapor pressure of pure liquid A. This is liquid B with what? Vapor pressure of pure liquid B. Then when mixed together, you have what? Solution. Take note, in this case, two of them, the two liquid, will exert their own pressure on the solution. The two liquid, they will exert, their vapor will exert what? Their own pressure on the what? Solution. This liquid A, the vapor of liquid A, will exert its own pressure on the solution. The vapor of liquid B will exert its own pressure on the solution. Therefore, the pressure exerted by what? The vapor of liquid A on the solution is known as what? Partial vapor pressure of what? Of liquid A in the solution. PA. That is partial vapor pressure. Partial vapor pressure of liquid A in the solution. That means the vapor of a liquid A exerts its own pressure on the solution. Then the pressure exerted by what? Liquid A on the solution. The pressure exerted by liquid A on the solution is known as what? Partial vapor pressure of liquid A. The liquid A, the vapor, will exert pressure on the solution. The vapor of liquid A will exert pressure on the solution. Then the pressure exerted by the vapor of liquid A is known as a partial vapor pressure of liquid A in the solution. Liquid B, the vapor of liquid B will also exert its own pressure. The vapor of liquid B will also exert its own pressure on the surface of the solution. Therefore, the pressure exerted by the vapor of liquid B on the surface of the solution is known as partial vapor pressure of liquid B in the solution or on the surface of the solution. Please take note of that. I said the two liquids are mixed together. Both of them will exert pressure. Liquid A, the vapor of liquid A will exert pressure in the solution. The vapor of liquid B will exert pressure in the solution. The pressure exerted by the vapor of liquid A in the solution is known as partial vapor pressure of liquid A. The pressure exerted by the vapor of liquid B in the solution or on the surface of the solution is known as a partial vapor pressure of liquid B in the solution. Take note of that. Then what is Raoult law? Raoult law states that the partial vapor pressure of a liquid in a solution. Let me take liquid A for an example. The partial vapor pressure of a liquid in a solution is directly proportional to mole fraction of that liquid in a solution. Please write it down. Please write it down. Let me write it down for you. Raoult law states that partial vapor pressure of a liquid in a solution is directly proportional to the mole fraction of the liquid in the solution. Take note. He said that the partial vapor pressure of a liquid on the surface of a solution is directly proportional to the mole fraction of that liquid in that solution. Here we have a liquid A in a solution. The partial vapor pressure of liquid A is directly proportional to the mole fraction of that liquid A in the solution. I can likewise say partial vapor pressure of liquid B is directly proportional to mole fraction of liquid B in the solution. This is what Raoult law is saying. This is Raoult law. Take me, Raoult law. You can pause the video and write it. That is Raoult law. Partial vapor pressure of liquid A is directly proportional to mole fraction of liquid A in the solution. Or partial vapor pressure of liquid B is directly proportional to mole fraction of liquid B in the solution. That means the partial vapor pressure of any liquid in a solution is directly proportional to the mole fraction of that liquid in the solution. That is Raoult law. Please, that is Raoult law. Please, Raoult law. That is Raoult law. What is the meaning of mole fraction? Mole fraction. Please, let me run this one off. What is the meaning of mole fraction? Mole fraction. Mole fraction of a liquid, let me take liquid A, is the mole of liquid A in the solution over mole of liquid A in the solution plus mole of liquid B in the solution. Take note. Mole fraction, X means what? Mole fraction. Then we are considering mole fraction of liquid A. Mole fraction of liquid A is what? The mole of what? Liquid A in the solution over the mole of liquid A in the solution plus the mole of liquid B in the solution. What will be mole fraction of liquid B in the solution? With what? Mole of liquid B over mole of liquid A plus mole of liquid B in the solution. Take note. And take note of this. Mole fraction of liquid A plus mole fraction of liquid B must be equal to 1. Take note of that. Please take note. Write it down. You can pause So that we are still going to solve for what? For a constant. We are going to change the proportionality sign. We change the proportionality sign to a constant. Take note of this. Mole fraction of liquid A plus mole fraction of liquid B must be equal to 1. That means mole fraction of the liquids, the two liquids in a solution, the mole fraction of the two liquids in a solution must be equal to what? 1. Write it down. Write it down. Let's move. Hope you've written it down. Please. Let's move. You've written this one down. I'll take note of this, please. Let's move. Let's move. From here, let me take this one. If I have PA direct proportional to this, that means partial vapor pressure of liquid A in a solution direct proportional to what? Mole fraction of that liquid A in the solution. PA, change the proportionality sign to a constant. I have K. You have this. We have this. We have this. Let us look for K. Let us calculate for K. If you want to calculate for K, let's calculate for K. Let me leave them. Let's calculate. Let's calculate for K. For K. Using the formula, vapor pressure of a pure liquid A equal to what? K times what? Mole fraction of liquid A. And I told you, the mole fraction of liquid A and mole fraction of liquid B must be equal to 1. If mole fraction of liquid A is equal to 1, what will be mole fraction of liquid B? Mole fraction of liquid B will be what? 0. Take note of that. If mole fraction of liquid A equal to 1, now this mole fraction of liquid B will be equal to 0. That means you will have what? Mole fraction of liquid A plus mole fraction of liquid B equal to 1. Mole fraction of liquid A is 1 plus 1. Mole fraction of liquid B is 0. What will you have? You have 1. Take note. Since I know that when mole fraction of liquid A is 1, mole fraction of liquid B is what? 0. Because I'm only considering what? Liquid A only. Therefore, I will have the vapor pressure of a pure liquid A equal to what? K. Mole fraction of liquid A is what? Times 1. That means we have vapor pressure of pure liquid A equal to what? K. Take note of this. Then substitute K in this formula. Substitute for K in this formula. Substitute for K in this formula. Since K equal to what? P naught A. Anywhere I see K from here, I'll change it to what? P naught A. And we have partial vapor pressure of liquid A equal to K is what? P naught A S what? A. Take note of this formula. If it is for B, I will have the same thing. I will have for B, P B equal to what? P naught B mole fraction of what? P. The same. Or should I write it down? Should I prove it for you? Should I? If for B, I want to calculate for B. For B, I will have the same P naught B equal to what? K mole fraction of what? B. That means when mole fraction of B is 1, mole fraction of A is what? 0. Change. You have P naught B equal to what? K times 1. Therefore, P naught B equal to what? K. Therefore, from this formula, from here, let me say P B equal to what? Mole fraction of what? Change proportionality sign. K naught B. P B equal to K mole fraction of B. What is K now? K is what? P naught B. Change it. You have this. You have this. This. You have this. Take note of that. You have this. Take note of this. This is Raoult law. That is Raoult law. That is Raoult law. Please. You can pause the video and write it down. You can pause the video and write it down. Listen, change the proportionality sign from here. Change the proportionality sign to a constant. We have K. Then let's calculate for K from here. I know that mole fraction of A, when it is 0, mole fraction of B will be 0. When mole fraction of A is 1, mole fraction of B will be 0. Then change mole fraction of A to 1. We have P naught A equal to what? K. Then go back to this what? Law. Anywhere you see K, change it to what? Mole vapor pressure of our pure liquid. Then you have this. Please take note. From this Raoult law, I change the proportionality sign to a constant. I have this. They are calculated for what? K from here. I take mole fraction of A to be equal to what? 1. Then I have P naught A, that is vapor pressure of pure liquid, equal to what? K. Then I came back to this formula. Anywhere I see K, I change it to what? Vapor pressure of what? Pure liquid A. Then I have this. The same thing to B. Take note of that. Please, take note. Please, let's move further. Let's move further. Let's move further. Let's move further. Listen. Can Raoult law be used to calculate total vapor pressure? No. We can't use Raoult law to calculate total vapor pressure. We can't use Raoult law to calculate the total vapor pressure. What we can use to calculate total vapor pressure is what? Raoult's law. Is what? Raoult's law. Is what? Raoult's law. That means we have total vapor pressure equal to what? Partial vapor pressure of A plus partial vapor pressure of what? B. That is Raoult's law. Raoult's law. Take note. Raoult law cannot be used to calculate total vapor pressure. Raoult law only show relationship. Take note. Raoult law only show the relationship between what? Partial vapor pressure and what? Mole fraction. Raoult law only shows relationship between partial vapor pressure of a liquid in solution and mole fraction of a liquid in solution. But to get the total vapor pressure, we use Raoult's law. Let us look at this. Now, total vapor pressure. What is partial vapor pressure of A? Partial vapor pressure of A is what? Vapor pressure of pure liquid A. You know that PA equal to P naught A XA. That means partial vapor pressure of A is what? Vapor pressure of pure liquid A multiplied by a mole fraction of liquid A. Change this one. And now P naught A times what? Mole fraction of A. Then plus partial vapor pressure of B. Change it. I have P naught B mole fraction of what? B. That is what Raoult's. Take note. Raoult's. Please take note. Raoult's. Take note. Raoult's. Please take note. Let's move further. Let's move further. Water is good. Let's move further. Let us go to the graph of Raoult law. Graphical representation 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 of Raoult law. Yes. One love, one heart. Let's get together and feel alright. Yeah, the children crying, one love. Yeah, the children crying, one heart. Give thanks and praise to the Lord. Graph of Raoult law. Raoult law. Raoult law. Graph of Raoult law. Raoult law. Okay, let's look at two liquids. Where you have the first liquid here, the first. Let's look at Raoult law graph for two volatile liquids. The first vertical line, or the first liquid, we have second vertical line here. Then we have our horizontal line. Horizontal line. This partial vapor pressure. Vapor pressure. We have this. where you have liquid A, mole fraction of liquid A, we have mole fraction of liquid B, mole fraction of liquid B, mole fraction of liquid A. Let me give you in a way you will understand. Look at this. I want to get what? The graph of partial pressure of each of the what? Volatile liquid in the solution. Two of them. Each of them in the solution. Each of those two volatile liquid in the solution. I take partial pressure as vertical for the two, for the first liquid, for the second liquid. For the first liquid, when mole fraction of the first liquid A is 1, and as you are moving from left, this is left to right, as you are moving from left to right, mole fraction of liquid A decreases, while the mole fraction of liquid B increases. As you are moving from left to right, mole fraction of liquid A decreases. Therefore, at the right, the mole fraction of liquid A will be what? 0. The mole fraction of liquid B increases. At this point, mole fraction of liquid B is 0. As it increases, mole fraction will be what? 1. At the right, mole fraction of liquid B will be 1. And take note, when mole fraction increases, partial vapor pressure also what? Increases. When mole fraction decreases, partial vapor pressure what? Decreases. Take note of that. When mole fraction of a liquid decreases, the partial vapor pressure of that liquid will what? Decrease. When mole fraction of a liquid increases, the partial vapor pressure of that liquid will also what? Increase. I told you, partial vapor pressure directly proportional to one mole fraction. Meaning that if this one increases, this one will also what? Increase. For A, mole fraction, as it is moving from left to right, the mole fraction decreases to what? 0. Let me put it up. The mole fraction decreases to what? 0. From 1, it decreases to 0. As the mole fraction decreases, what happens to the partial vapor pressure? The partial vapor pressure will also what? Decrease. That means from here, partial vapor pressure decreases. Partial vapor pressure decreases. This is what? Vapor pressure of what? Of pure liquid A. Then the partial vapor pressure decreases to what? 0. That means we have partial vapor pressure A equal to what? P naught A times what? Mole fraction of A. It decreases. Partial vapor pressure decreases. As mole fraction B increases, it increases as it is moving from left to what? Right. From SB to be equal to 0, it increases to what? SB equal to what? Ma. And don't forget, as mole fraction increases, what happens to partial vapor pressure? It also what? Increases. Mole fraction of B increases from 0 to what? Ma. Therefore, the partial vapor pressure will also what? Increase. And partial vapor pressure, partial vapor pressure increase. Partial vapor pressure increase. This is partial vapor pressure of liquid B equal to vapor pressure of pure liquid B times its mole fraction. Take note of this. This one, this liquid A is more volatile than what? Liquid B. This one is less volatile. Then for you to find the total vapor pressure from here, the total vapor pressure, this is the total vapor pressure. The total vapor, let me rewrite this. This is the total vapor pressure. The total vapor pressure equal to partial vapor pressure of A plus partial vapor pressure of B. That is what total vapor pressure. This is what is the Raoult law graph looks like. This is Raoult law graph. Please take note of that. Raoult law graph. Please take note of that. Let us look at some numerical questions. Let us look at some numerical questions. Let's look at these numerical questions. For more questions, there will be a particular video on this where we are going to solve a lot of questions. Many questions will be solved on this. But let us look at these two questions before we end this video. Please don't forget to subscribe to our YouTube channel. Share this YouTube channels with your friend for JAM, for WIEC, and mostly JUPEB. Your 300 and above is sure in JAM, and your 3.8 are sure in what? In JUPEB. Please, for physical and online classes, both on JUPEB and JAM, you can contact us, call any one of those two numbers on your screen. You will see a WhatsApp link below. You can punch or press punch. It will be okay. Punch the WhatsApp link so that it will take you directly to our WhatsApp group. And if you have so many questions to ask, that WhatsApp group is there for you to ask your question. For physical and online classes, please, you can call one of those numbers or punch the WhatsApp link below this video on the comment section. Please comment, like, share this video with your friend on JUPEB, JAM, WIEC. Your success is what sure. Please, let's move. The first question, solution one. The first question says 0.46 grams of ethanol and 0.32 grams of methanol are mixed. Don't forget, two of them are volatile liquids and they are pure liquid. Two of them are mixed. We are given mass of ethanol. Ethanol is C2H5O8. The mass of ethanol is given as 0.46 grams. 0.46 grams. Then we have mass of methanol. Methanol is for CH3OH. CH3OH. That one is given as 0.32 grams. Then we are given vapor pressure of pure ethanol. I told you P naught is for vapor pressure of pure substance A. The vapor pressure of pure liquid A. That is P naught A. The vapor pressure of pure liquid A, or the vapor pressure of liquid A. In this case, we are given vapor pressure of ethanol. Now the P naught ethanol, let me use E. That is the vapor pressure of pure ethanol is given as what? 400 millimeter mercury. And the vapor pressure of pure methanol. P naught N, vapor pressure of pure methanol. The vapor pressure of pure liquid is for P naught. Then this is methanol. Vapor pressure of pure methanol is given as for 200 millimeter mercury. Then the question says, find partial vapor pressure of both ethanol and methanol. Before you get the partial vapor pressure, don't forget, let us look at what is the molar mass of methanol, what is the molar mass of ethanol, what is the molar mass of methanol. Molar mass, ml, of ethanol, of C2H5, let me write it to molar mass of ethanol, C2H5OH, molar mass. Carbon is for 12, that is 12 times 2, we have 24. Hydrogen is for 1 times 5, now plus 5. Oxygen 16, then hydrogen plus 1. The molar mass of ethanol is for 46 grams per mole. Let us look at molar mass of methanol. Molar mass of methanol, which is CH3OH. That means carbon is 12 plus hydrogen 1 times 3 plus oxygen 16 plus hydrogen 1. Here we are 15, 31, 32 gram per mole. Then we can use this before you can calculate for partial vapor pressure. Don't forget, you have to calculate, use the molar mass and mass to calculate their mole. Then get the mole fraction of each liquid in the solution. Mole fraction of each liquid in the solution. How can we do that? What about calculate what? The mole of what? 0.46 grams of ethanol. Now, mole of ethanol, C2H5OH, equal to mass of ethanol, which is 0.46 over molar mass of ethanol, 46. This will give you what? Everything will give you what? 0.01 mole. Then for mole of methanol, mole of methanol is what? Mass of methanol, which is 0.32. Mass of methanol is what? 0.32 from the question. Mass of methanol all over molar mass of methanol. What is molar mass of methanol? 32, which will give you 0.01 mole. You've gotten that, please. You've gotten that. Then find mole fraction of ethanol. Mole fraction of ethanol. Let me use E. Ethanol. That is this one. E. Ethanol. This is ethanol. This is methanol. Ethanol. Mole fraction of ethanol is what? Mole of ethanol over mole of ethanol plus mole of what? Methanol. Therefore, mole fraction of ethanol. What is mole of ethanol? 0.01. 0.01 over mole of ethanol 0.01 plus mole of methanol 0.01, which will give you 0.01 over 0.02, which will give you 1/2. 1/2, take note. 1/2. Mole of what? Mole fraction of ethanol is 1/2. Let's also look for mole fraction of methanol. Mole fraction of methanol. Mole fraction of methanol. Please, mole fraction of methanol. Methanol is N. Mole fraction of methanol equal to what? Mole of methanol over mole of ethanol plus mole of what? Methanol. Take note of that. Mole fraction of methanol equal to, what is mole of methanol? The same thing, 0.01. Mole of methanol is for 0.01. What is mole of ethanol? Mole of ethanol is 0.01. 0.01 plus mole of methanol 0.01, which will give you what? 0.01 over 0.02. Therefore, mole fraction of methanol equal to 1/2 also. 1/2. And don't forget, I told you, the addition of mole fraction of the two liquids in a solution must give you 1. Mole fraction of methanol 1/2 plus mole fraction of ethanol 1/2. Add the two of them together, you must get what? 1. Addition of what? Mole fraction of two liquids, of two volatile liquids in a solution must give you what? 1. Please take note of that. Then from here, the first question says, find the partial vapor pressure of both ethanol and methanol. What is the formula for partial vapor pressure? But partial vapor pressure. Therefore, partial vapor pressure of ethanol equal to vapor pressure of pure ethanol multiplied by mole fraction of ethanol. Take note of that. Partial vapor pressure of ethanol equal to what? Vapor pressure of pure ethanol, P not E. Vapor pressure of pure ethanol. This one is partial vapor pressure of ethanol in the solution. Partial vapor pressure of ethanol in the solution. Partial vapor pressure of ethanol in the solution. This is vapor pressure of pure ethanol. Let me rewrite it. PE is what? Partial vapor pressure of ethanol. P naught E is what? Vapor pressure of pure ethanol. Take note of that. The question says calculate partial vapor pressure of ethanol, which is P naught from PE. This one is unknown. That's what we want to calculate. Therefore, we have partial vapor pressure of ethanol equal to what is vapor pressure of pure ethanol. The vapor pressure of pure ethanol in our question is given as 2. The partial vapor pressure, that is what you want to calculate. Then the vapor pressure of pure ethanol is given as what? 400. Then multiplied by what? Mole fraction of ethanol, which is 1/2. Then from here we have partial vapor pressure of ethanol is what? 200 millimeter mercury. Then for partial vapor pressure of methanol is what? Vapor pressure of pure methanol multiplied by mole fraction of what? Methanol. Then partial vapor pressure of methanol equal to vapor pressure of pure methanol is given as what? 200. Then what is the mole fraction of methanol? Mole fraction of methanol is what? Half. Therefore, from here you have what? This one is what? 100 millimeter mercury. Then the second question says, this is question 1. The second question says, calculate the total vapor pressure. That means we calculate total vapor pressure using what? Dalton's law. We have now PT equal to what? PE plus what? PN. Therefore, we have 200 plus what? 100 equal to what? 300 millimeter mercury. Take note of that. That is what? Total vapor pressure. That is total vapor pressure. That is total vapor pressure. Let's move to the second question. The second question, please pause the video and look at it. Please, if there's anything you don't understand, you can communicate with us on the WhatsApp group, on the link. Please take note. For the online class and physical class, so that we can help you on this. Take note of that. Let's move to the second question. Let me run this. Let me run it off. Solution 2. Solution 2. The second solution, which is this? Solution 2. This one is straightforward. Second solution. We have if one mole of ethanol. We have mole of ethanol. That one is E for ethanol. Mole of ethanol is given as 4 moles. Mixed with 1 mole of acetone. 1 mole. 1 mole of acetone. Find the partial vapor pressure of ethanol and acetone. Partial vapor pressure of ethanol unknown. Partial vapor pressure of acetone unknown. Then we are given the vapor pressure of pure ethanol. The vapor pressure of pure ethanol. Vapor pressure of pure ethanol are 70 mmHg, millimeter mercury. The vapor pressure of pure acetone is given as 80 millimeter mercury. You now say calculate what? The first question, partial vapor pressure of ethanol and acetone, then calculate your total vapor pressure. Before you can calculate partial vapor pressure of ethanol and acetone, you have to calculate their mole fraction. Calculate the mole fraction of ethanol. Let us calculate the mole fraction of ethanol. Let's calculate the mole fraction of ethanol. Mole fraction of ethanol is what? Mole of ethanol over mole of ethanol plus mole of acetone. We have mole fraction of ethanol. What is mole of ethanol? 4. Over mole of ethanol 4 plus mole of acetone 1. That means mole fraction of ethanol is what? 4 over 5. Let us look at mole fraction of acetone. Mole fraction of acetone is what? Mole of acetone over mole of ethanol plus mole of acetone. Therefore, mole fraction of acetone equal to what is mole of acetone is given as 1 over mole of ethanol 4 plus mole of acetone 1. That means mole fraction of acetone is 4 over 5. Addition of the two will give you what? 1. If you do it. Mole fraction of ethanol plus mole fraction of acetone. Mole fraction of ethanol plus mole fraction of acetone must give you 1. What is mole fraction of ethanol? 4 over 5. Mole fraction of acetone is what? I'm sorry, here is 1 over 5. 1 over 5. That is 1 over 1 over 5. Mole fraction of acetone is what? 1 over 5. Else here, 5. 5 in 5, 1. 4. 5 in 5, 1. That's 1. 1. We have 5 over 5, which is what? 1. Can you see? 1. You must get 1. Please take note of that. Addition of mole fraction will give you what? 1. Take note. Take note. Let's move further. Let's move further. Then the question now says, find what? Partial pressure of ethanol. What will be the partial pressure of ethanol? Partial pressure of ethanol equal to what? Vapor pressure of pure ethanol multiplied by mole fraction of what? Ethanol. Partial vapor pressure of ethanol equal to vapor pressure of pure ethanol multiplied by mole fraction of what? Ethanol. I repeat. Partial vapor pressure of ethanol equal to what? Vapor pressure. This one is partial vapor pressure of ethanol equal to vapor pressure of pure ethanol multiplied by what? Mole fraction of ethanol. This one is what we are looking for. PE equal to what is P naught E? P naught E is given as 70 times what? This one is what? 4 over 5. From here, we have PE equal to 5 here 1. 5 here is what? We have 1. Here we have 4. That is 14 times 4. Therefore, partial vapor pressure is what? 14 times 4 will give you 56 millimeter mercury. 56 millimeter mercury. Let us look at what? Partial vapor pressure of acetone. That is the same formula. Partial vapor pressure of acetone equal to vapor pressure of pure acetone multiplied by mole fraction of acetone. Partial vapor pressure of acetone equal to what? Vapor pressure of pure acetone times multiplied by what? Mole fraction of acetone. Therefore, partial vapor pressure of acetone. What is vapor pressure of pure acetone? Is given as what? 80. 80 multiplied by mole fraction of acetone 1 over 5. From here, we have partial vapor pressure of acetone equal to 5 here 1, 5 in 80, we have 5 in 8. What do we have? 5 here, we have 1 in 3, we have 36 millimeter mercury. Okay, 5 here 1. Okay, I'm sorry. That means we are in what? 16, millimeter mercury. We have 16 millimeter mercury. I'm sorry, I was thinking of another thing, millimeter mercury. But the next question now says the total vapor pressure. The total vapor pressure. Calculate the total vapor pressure using Dalton's law. Dalton's law. Calculate the total vapor pressure using what? Dalton's law. The total vapor pressure using what? Dalton's law. That means you have total vapor pressure equal to what? Partial vapor pressure of ethanol plus partial vapor pressure of acetone. Therefore, the total vapor pressure is what? What is partial vapor pressure of ethanol? 56 plus what? Partial vapor pressure of acetone, they are 16. Therefore, the total vapor pressure will give you 2672 millimeter mercury. 72 millimeter mercury. Please, don't worry. We are here to give you the best. We are here to give you the best, the concept, both in physics and chemistry, and also, let me add math and biology. Neo TISA will give you the best. Neo TISA is for JUPEB student, JAMB student, YX student, from SS1 to SS3. If you want to know, have the knowledge of physics and chemistry, you can contact any one of those two numbers on your screen or press the WhatsApp link below. For JUPEB student that wishes to have 3 distinctions, please press the WhatsApp link below, or you can call one of those two numbers on your screen. For JAMB student that want to have 300 and above, you can also press the WhatsApp link below or call one of those two numbers. Please, my name is Jama. I remain your best. Please share this link to your JUPEB friends, the JUPEB student, all your friends, your JAMB student, which are your friends, and comment, subscribe. May God bless us all. Thank you.